going to do a video on the number of solutions a linear equation can have. And I probably put this in the wrong order, but that's fine. I'm going to show you, starting with our purple. What I would do. So first, I would subtract 2x from both sides. And I'd say, all right, 3x minus 2x is x. Bring down my -4, bring down my +1. Now I'm going to add the opposite. Now I'm going to add the opposite to both sides. So I'm going to bring down my x, and I get x equals 5. Now, we're going to stop here. I'm just going to circle this. X equals 5. That is the solution for this equation. 3x minus 4 equals 2x plus 1. And what that means is if I take 5 and I plug it back in, 3 times 5 minus 4, does that equal 2 times 5 plus 1? Well, let's see. 3 times 5 is 15, so I have 15 minus 4. And I'm trying to determine, does that equal 10 plus 1? And sure enough, 11 equals 11. So there is one solution. And the thing is, there's only one solution for this equation. 5 will work, but no other number you plug in will work. And if you don't believe me, plug in other numbers. Type it into your calculator if you have to. But if x equals 0, this would become -4. And this side, the right-hand side, would become +1. -4 does not equal +1. So there is one solution. Over here, I'm going to take a quick look. And what happens if I have this? Well, if I subtract 3x from both sides, what I end up with is I bring down my -4, I bring down my +2, but I also have to bring down my equal sign. This says that -4 equals +2. Well, that's clearly not true. That's never true. And the reason why is because, well, hopefully you're noticing this. I started with 3x minus 4 equals 3x plus 2. Well, x, no matter what value we pick for x, if we picked x equals 5, this 3x would become 15, but so would this one. And then I had to subtract 4, and I had to add 2. So 15 minus 4 is 11. 15 plus 2 is 17. Obviously, that's not going to work. But it's never going to work, because if I pick any value for x, let's say x equals 0, this, once again, becomes 0, and this becomes 0, but I get -4 and +2. If x equals -1, this would become a -3 minus 4, which would be a -7. This would be a -3 plus 2, which is a -1, and clearly -7 and -1 are not the same, because the variable term on both sides of the equation are exactly the same. These are our variable terms. Because they're exactly the same, but the constant term is not, they will never be equal. So there's no solutions ever. Nothing will ever work for that. So let's take a look at this last one. Here, my variable terms are the same, but so are my constant terms. So what does that mean? Well, let's see. If I subtract 3x from both sides, I'm going to get -4 equals -4. And that's always true. So over here, I said never true for any value of x. Here, I'm saying it's always true, and that's also for any value of x. So let's take a quick look. If x equals 5, this would become 15 minus 4, which is 11. And this would become 15 minus 4, which is 11. And that's certainly true. If I were to change my color to yellow, and I said x equals 0, this would become this would become -4, and this would become -4, and that's obviously true. If I were to make this a negative, let's say x equals -2, let's see, 3 times a -2 is a -6, minus 4 is a -10, 3 times a -2 is -6, minus 4 is a -10. You can see it's always true no matter what value of x we pick. So you might be wondering, how on earth can you tell? Well, once again, here our variable terms are the same, but so are the constant terms. All right? And what I'm going to suggest is this. Let's call this what it is. It's 2 terms. This is 2 terms. And so when we have 2 terms, we call it a binomial. All right? So binomial. So what I'm going to suggest is this. We're going to say if our binomial expression on the left, if this binomial expression on the left is exactly the same. I'm not going to say it's equal to, because these are all equal to. If it's exactly the same as the binomial expression on the right, then you will have an infinite number of solutions. If the binomial term on the left has the same variable term as the binomial expression on the right, but the constant terms are different, you will have no solutions. And if the binomial term on the left has a different variable term than the binomial term on the right, you will have one solution. So let's take a look at 3 examples. Here we go. Well, the problem is these are not expressed as 2 binomials set equal to each other. So what I'm going to do is I'm going to get rid of these parentheses. I have, that's going to become 8x minus 4. I'm just going to distribute. And this is going to become 3x plus 15. Now, I don't need to solve this out. What I need to do is I need to take a look at my expression on the left and my expression on the right, my binomials on the left and my binomial on the right, and I'm going to determine, do they have the same variable term? Well, let's see. Here I have an 8x, and here I have a 3x. They do not. They do not have the same variable term, so there is going to be exactly one solution. And if I wanted to solve it, I could and figure out what that one solution is. I'm not going to. Let's take a look over at this one. Here I have 2x plus 3x minus 2 minus 8. So that's a 2x plus 3x is 5x. Negative 2 and a negative 8 is a negative 10. Equals 5 times x is 5x. 5 times a negative 2 is a negative 10. So, well, let's write this so you can actually read it. Oh, goodness me. 5x minus 10. Now you can see I have a binomial term on my left. I have a binomial term on the right, and they are exactly the same. They're exactly the same. And by that, what I mean is I have my variable term on the left is 5x. On the right is 5x. The variable term on the right is 5x. My constant term is negative 10. My constant term over here is negative 10. These two expressions are exactly the same. There is going to be an infinite, oh, goodness me, number of solutions. Any number you choose and place into x will yield a true statement, right? And once again, if I picked 3, that'd be 15 minus 10, which is 5, equals 15 minus 10, which is 5. All right, my last one. I know what you're thinking. Well, the first one was 1, the second one was infinite. This should probably be 0. So let's see if that's true. Oh my goodness me. So I have 6 times x, which is 6x. 6 times the negative 1 is negative 6. 2 times 3x is 6x. 2 times 1 is 2. And now you can see my variable term on my left-hand side is the same as the variable term on my right-hand side, but my constant terms are different. Therefore, no solution will ever make this true. No solution. No, I'm really, really, really not liking the new whiteboard. No solution will ever work. All right, and once again, the reason why is because if you subtract 6x minus 6 equals 6x plus 2. If I subtract 6x from both sides, I get a statement, I get an equation, which is not true. I get negative 6 equals positive 2, and that's obviously never true. And because the variable terms are the same, there's nothing that can ever change that. All right, I hope that helped. I hope you enjoyed this. Thank you. Bye-bye.